Okay, so I want to present a bit what happened in Pharo over the last year with regards to variables in the language. So this will not be a presentation, so even so, I do have some slides as my own kind of plan of what to talk about, but I want to actually show it live in the system, all these things. So I will try to actually share my Pharo image. Yep, and this is it. I hope you all see it, because now I will use this to show everything. So variables. What I will do first is that I will explain what variables we have in a Smalltalk system, to then later explain how we extended that in Pharo. So the first thing that we know is we have a lot of different kinds of variables. So for example, if we have something like this is a global variable, so we can actually execute it, print it, and it gives a result. And this is a variable in the global namespace. Then we have things like temporary variables that we define like this, temp. And this one we can assign and do something with well-known. The next thing that we have is that we have instance variables, which we can see in a class definition here of point, for example. So point has two instance variables, one is x and one is y. And if we make a new point, for example, by using the add message, then we can inspect this and we see, okay, this point has x and y is 5. Then in addition, there are some special variables that are not used that often, but that are important too. So one that we can see in the class Smalltalk image is class variables, which are shared in the hierarchy and between the class and its meta class. And the last thing that we have is pseudo variables, where we have something like this context, for example, which prints out the current execution context, or things like self and super to send a message to self, or to send a message to self where the lookup starts in the super class. So these are the kind of variables that we have. And we do have, of course, for all of those, some reflective features. So for example, an instance variable we can read using, so if we go back to our object here, we can read this from the outside using something, for example, like inst var named x, and it will return the value. We can only do that via the object, so we can send a special method to the object, which is a reflective method, which does this read. Instance variables themselves are actually known by the class. So, for example, point has them in its definition, but as you can see, it's just a string and nothing else. And the instance variable are read by the virtual machine using the offset of the variable definition and the class hierarchy. Temporary variables are have the same kind of feature that we can define a temp. So, for example, we can define a temp in a block here, assign something to it, and then we can read it reflectively via the execution context. We can say this context, temp named, oops. And if we now evaluate this block, it should actually return the value of this variable, and it works. This looks quite simple, and you would think that, yeah, that's a bit similar like with these objects. So for sure, this is just an offset in the context, which it used to be in Smalltalk 80, but with closures, this gets actually really, really complicated. More complicated than you ever want to know, because of course, depending on how the variable is used, if it escapes its definition context, it's allocated differently, and so it's actually quite some work to read this variable. This
Quick
is
question. In terms of like variables,
yeah.
What about like arguments? Do you consider them like read-only locals, or?
So yeah, so arguments are actually historically managed as temps. Originally in Smalltalk 80, there were really temps, and you could even assign to them, which of course leads to really bad bugs. And so that was changed in Squeak at a very early age. So when I joined around that time, that was one of the changes that a student did to actually make them read-only. And of course, today they are read-only too, but they are kind of considered as temps. So the bytecode to access an argument is still the temp access bytecode, for example. So, and globals are actually interesting because we can, as we will later see, because they are the only variables where we do have an object. But that's something that will come in a second step. So globals we can read, of course, reflectively from the global namespace. So if we say Smalltalk globals at object, and somehow my keyboard doesn't work anymore. At object, then it returns the object. Or we can ask the class. So in case of classes, this is possible. We can ask it for its binding. Why does my keyboard not work anymore? Binding, which returns us an association, which of course we can say value, and then we get back the value of the variable. And class variables and pool variables are the same, so they are just associations from other dictionaries, not the global one, but there's a dictionary per class, and you can share a class dictionary using the pool import feature too. So these are variables, and the question that now, of course, people always say in Smalltalk everything is an object, and so now your questions, of course, for sure variables are objects too, and there the problem is not really. So if you look at this case of globals, we do have an object for them, but it's just in Smalltalk 18 association. This is already not too bad because we have one object per defined global variable, but it does not have an API. So there's no meta level API to do it, but at least we do have an object. But if we look back at all the other kinds of variables, so for example, instance variables do not really exist. So the only thing that the system knows, so for example, point, so for example, we can ask point for all its, oh, this is not good. Point, we can ask for all its instance variables, instance variable names, and this will return us the names of the instance variables. But that's the only information that the system has about this variable. So the variable x, the instance variable x and point, we know the name and that it is at index 1. That's it. Nothing else exists about this variable in the system. There's no object representing it. There's no meta API, nothing. From the bytecode level, the compiler then says, oh, it's an x, a variable x in point. I can ask for all the instance variable names, and then I find the offset, and this is how I know which bytecode to generate. So that's it. There is no object. For temporaries, is this. So if you look at a compiled method knows nothing about even the names of temporary variables. So to get the name, so if you look at a method, so for example, we can go to object halt. Let's see. We can say object halt and inspect it. Oops. Then inspector has different views, and we can look at it. So either in the raw view, which shows us the literals and the bytecode, or we can look at the bytecode in a higher level representation, which is kind of nice, and then we can even see this source code at the side. And this shows, if we go to the raw view, go back here. Oop. How do I close this? If I go to the raw view, there is no information about variable names inside. The only thing that we have here the variable that, so the reference to the global halt, that's there as an object. We have the name of the message that we send, so we send halt now, and then we have the bytecode as numbers, but there's nothing else of interest. The only other thing that we have is a pointer, is the information of the name of the method and the class, which actually is information that in Smalltalk 80 was not encoded because of memory constraints. Even. So that means as soon as we have a method, if you have a method with temporary variables, you need the compiler and the source code to make any sense of the variables. Which in turn, so the other problem is that reading temps is extremely difficult due to the closure model of the language. It's actually impossible to make sense of this without the compiler presenting, generating some kind of map of all the variables and where to find them. So that means that this is not easy at all. And the reason, of course, for that is that there is no object modeling this variable. The question is now, can't we do better? So of course, if we go back to 1978, 1980, not really, because the original Smalltalk system could, I think, only allocate 64,000 objects, and there was almost no memory. So of course, this was the best you could do back then. But if you then think about how much resources we have today, then I think we can actually do better. And that's what we tried to do with Pharo. So one thing that we did slowly is to actually reify all the kinds of variables that I've shown until now. So that means that for all of these variables, we have a class that models them. We have a class hierarchy that starts in variable with the class variable. Variable. So we browse that, we see, okay, we have a class that describes a variable, and the only shared knowledge of all variables is that it has a name. And then we have a quite extensive class hierarchy, which actually, if you look at the full one, is quite large, partly because it has lots of things that I will show later, and quite some experiments that might go away in the future again. But we can see that we have all the things that you would expect in this hierarchy. So we do have a class variable, we see global variable, we see undeclared variable, which is kind of interesting that this exists. Workspace variables, which are actually the variables that are known by the workspace, like this temp here. That was created when I actually assigned the temp variable. And we do have local variables where we see we do have arguments, and argument returns false for it's writable, so it's not writable. Then we have, because local variables are complicated, we have quite some other things. So we've copied local variable, we have temporary variable, which is normal one, and then we have a variable that lives in a so-called temp vector because it needs to survive its execution context. Then we have self, super in this context, modeled as variables, and we will see that later more in details. And then you have a hierarchy for the instance state. historically, so back when this was done first, inspired by CLOS, it was called slot. I'm still a little bit hesitant if we shouldn't just call it instance variable. So the class name could be instance variable. But if you look down in the one that we use for instance variables, actually is called instance variable slot. So this is the variable that actually models instance variables. Yeah, so this is the hierarchy, and I will explain a bit of what we can do with these and what things it has. So one thing is that we can, of course, now ask point instead of the names, we can now ask it for its instance variables. So we have even it's an accessor for that, and if we inspect that, we get back two variables, and these are objects that describe the variables in points. So that means it has a name, for example, the x. It knows the class where it's inside. So we have owning class and defining class, which is a bit odd because we do support stateful traits. So that means traits can actually define an instance variable, and then you can install that trait in a class, and then this this instance variable knows that it's in the trait, that it's in the class, but it comes from a trait. That's why this is a little bit more complex. And then we have the index, which the VM needs to know to read the variable. The nice thing about this is now that it actually does have, because it's an object with its own class, it does have an API. So for example, we can now ask it for using methods, which would be, in that case, all methods, if we inspect it, all methods that use X in some way. Use mean either assign to it or read from it. And if we go through, we see, yeah, these are all the methods that access X in some way. So this is for the first idea that we can actually inspect all these things. For instance variables or for all kinds of variables, the next thing that you want to do with an API is, of course, you want to be able to read and write a variable. So if we have our variable in hand here, then the question is, how can I use this to read a value from a point? And the question is, of course, it has an API to read. So we can just say read, and then we give it a point, so like 4 or 5. And if we now execute this and print it out, it will give us the variable 4. If we use the second instance variable, this will give us 5, because the second, if we inspect it, it's the Y instance variable. The nice thing is that actually this read method does not can read the object without sending a message. So if we go into the implementation of this, then we see that it actually, so the implementation is self object inst read. And if you look in this implementation, we see that it actually here uses the mirror primitive that is normally in the context. Well, it was originally put in context, because where do you put this method if there is no object for this variable? And this means that we can actually read reflectively without sending a message, which in kind of, if you think about it, means that these variable objects are a little bit like specialized mirrors. So they are meta objects that know how to read or write state in an object. So we can even write state to the object. So for that, we need to first have the point in hand. So let's do that. And then we can use, what's the API? Let's write 7 point. Execute that, and if we now inspect point, then Y7. So we do have a reflective API now nicely on the variable objects. For globals, this is a bit the same. So as you saw, so I actually, when I did this thing with binding and I printed out, it prints like an association. The reason for this backward compatibility, because in Pharo, this is actually not an association, because if I ask what's class, then it's a global variable. So that means it is compatible to associations, so it can actually play the role of an association in a dictionary, and that's why how we can actually have now in Smalltalk globals. So if we say Smalltalk globals associations, if we do this, then we get back global variable objects. But as they are compatible to associations, they can just play the role of an association in the dictionary. Just works, which is kind of impressive. So that means too, it has the old API of value that you are used to, so we can do that. Or we can use read the variable to have an API that's more close to the API of the other variables. So that's nice. And of course, we have the same API like the other one. For example, we can say using methods, size, and then we know, okay, 522 methods actually access the global, which is kind of nice. And we can inspect it and look at the source code like this. You see always somewhere object. That is globals. For temporal variables, we can do that too. So for example, imagine we have, so I took as an example, linked list. This was the first that I found with a nice temp. There we can now say temporal variable named. If you look at this, so it does have a temp, so it should return that. So if we do this, then it returns actually an object, and if we inspect it, it tells us this is a temporary variable, and it's actually used the right way. Interesting. The compiler decided that it actually is written to multiple times. If you now think about temporary variables, there are a lot of them in the system. And of course, we do not pre-allocate 250,000 objects for all the temporary variables. So that means that temporary variables are a bit special, because this temporary variable is created on need, and it lives as long as the AST of the method lives. So we have the
question. So I understand things like instance variables, their objects are actually installed within the class, so they have stateful persists.
Yeah.
Cool.
Exactly. And you can even check, so you can say instance variable slot. No, indexed instance variable. I think it's index. What is that called? Ah, I forgot to talk to you. Let's look in the.
I was curious if you just inspected point, the class.
Yeah, so what we can, we can inspect point, and then we can see what it does. So it actually, so what it does, and I will show a little bit about that later, we actually have first class layouts too. So that means that the layout of class, which in Smalltalk 80 is just an integer, just a flag for the VM, is in Pharo, it's an object. And that's layout, in this case a fixed layout, it has an array-like object and called a scope, and this scope actually has these two variables inside.
Oh.
But what I wanted to do is I wanted to check how many of these we have in the system. So we can just say instance variable, so we can for one inspect it and put. No, that doesn't work. No, that's not what I wanted. So we can ask how many instances do we have of this? So all instances size, and it comes back with 12,489, which of course for 1980 would be impossible to have 12,000 objects describing instance variables. But today, I mean, this whole image is 60 megabyte large with a lot of code inside, like 120,000 method. It actually is not impossible to do that. But when we then go to the temporal variables, there it is not really possible, because at some point counted, I don't remember, I think we have, even so we have 100,000, 120,000 methods, we have maybe 100,000 or even less, maybe 80,000 instance temporal variables. But it does not make sense to have them all instantiated. And so they are actually created on demand, like the AST. So if we ask for the AST, so we use the AST a lot in the system, so much more than in Smalltalk 80, because it's not, we don't see it only as a compiler internal data. We use it a lot for many things. And we use it for all the things that you do with code. So we use the same AST to do syntax highlighting, code completion, code generation, and refactoring. So that means we do have an AST for that we can ask for every method. And this is actually an RB AST, and we have a nice special inspector to make it easy to look at it. And I don't know why it stopped highlighting here, so normally it should highlight the source code here. Yeah, so we have the AST, and the temporal variables are alive as long as the AST is alive, which is for now quite crude. So it actually does have caches the AST until you shut down the image, which was done with this idea like, let's wait until it breaks because it's too trivial, but until now it works quite fine, which is amazing. But of course, it's something that we need to improve in the future. Yeah, so these are temporal variables. And the next thing, what else is interesting to know? Yeah, so all variables actually know its scope. So if we do this point, so if we ask for the X slot, then we can ask, what is the scope of your definition? And this one will tell, oh, I'm defined at point. So that's nice. And it's kind of natural. I mean, an instance variable is defined in the class. And then if we ask a global for its scope, it of course answers. If you do object binding scope, it will tell us, oh, I'm in the system dictionary. So that means every variable has a scope, and if you ask for that name in that scope, you will get back that variable. But in addition, all these scopes are actually concatenated. So that means that the global scope is the parent scope, the most outer scope, and then all the other scopes know their outer scope. So if we ask the instance variable of the point X for its outer scope, then it will tell us my outer scope is the global scope. And if we have a temporal variable in hand, let's see if we can get back. No, certainly not. No. Oh, this one is not too bad. I have to type everything again. So if we have a temporal variable in hand, oops. Yeah, this one we can ask for its outer scope too. And this should give us, oh no, this does not actually. Oh, that's strange. Yeah.
Maybe you need to go scope, and it's scope, and then it's outer scope.
Ah, yes, right. You're right. Scope. This will give us again the class, because the scope itself is the method scope. maybe do this, yeah. And the outer scope is the class again. Like yeah.
One question. What about the scope of pool var?
The scope of a pool var should be the class itself too. So if we, or no, it's I think it's the dictionary. Let's check. Let's get a pool variable from Smalltalk image. Smalltalk image. Oh no, this is an instance. Where do we have pool variables? Let's search for pool. So we don't use pools that often anymore. So we even hide the possibility. But we do have, no. We should have some pools somewhere.
Just look for subclasses of shared pool.
Ah, yes. No, we can use test shared pool. That's good. So test shared pool. So the thing is that so in Smalltalk 80 you could use any dictionary as a pool. In Squeak back then, Andreas changed it at some point to be more declarative, which was a really nice move. And so he said, why don't we use class variables of a class that is a subclass of shared pool to define pool variables, which is nice because it makes it immediately from something that you just create while filing in some initialize method to something that is stored as code in a declarative form. So that means the pool variable itself here is, of course, so if we ask this one, so we can, so one thing that I wanted to show next is that we do have something called lookup bar, which actually, instead of knowing, which is kind of variable this is, we can just ask, if we know that there is a variable name and we want to get the variable, we just say lookup bar. And so we do that, we get back the correct variable, and if we ask the class for that, it actually is a class variable, which is clear because it is a class variable in test shared pool. But the user of that, do we have any users using classes? Does that work? Or users? It has no users. So let's look for another one of these subclasses of shared pool. Hierarchy. Let's take FFI constant. So that's nice. How can we get the users? I forgot the API name. Pool users is the name, because users are actually just the normal class users. Pool users. So if we inspect pool users, then we get back all the users of it. So let's try. So we now have this one, and now we want from FFI constants, we would take one of those names and we look it up. And the question is what to get back, and we get back class variable. That means for now, pools are just modeled as class variables. And if we now ask it for its scope, then it will get back FFI constants, because that's where it originally came from. That's for now the model that we have for this. So I wanted to, as a next thing, actually explain lookup var, and I did already. So lookup var is a method that you can send to any object that is a scope, and it will look up the name in the hierarchy. So this means that we can do this even in an example like in a block to read a temp, like we did at the beginning. So if we have a temp, we assign it something, and now we can actually they say this context lookup var, And in this case, we first use temp. And if we evaluate that, then we get back the temp. But the nice thing is that as this goes up the hierarchy of the scopes, we can ask any kind of name and it will return the object. And now the question is, for what would you need this feature? Especially if you, so for what would you need this feature? And for what you need it is that you can actually read these variables easily. And for that, we do have actually an API that any variable that exists understands reading context and can read itself from a context. The reason why this is the API to read any variable is that temps you can only read if you have a context in hand. So that means that the minimal thing that any variable could have as an API to read is to read itself in a context. And so we added actually reading context to all these variables, and it can read the variable. So in this case, on a global, it returns object because it just ignores the context. But if I give the temp here, it actually reads the temp. And that regardless of how complex. So in the case of temps, I mean, this could be really complex. It could be actually allocated in a temp vector because it actually escapes its definition context and all these things. And this is all hidden away and very simple to use. And where is this used? And the answer is, of course, in the debugger. So imagine we have the debugger in some case where we have a temp. So let's do it here. So we say here, we say self halt and execute. So now we see, okay, do it, nice. But what is interesting is that you can now just highlight something and press P and it prints it out, which is very natural for small talkers. But did you ever ask yourself how this actually works? Because this is much more complex than you would ever expect. And we can actually find out by just putting a halt inside and executing this. And this will then, of course, open another debugger, but on the code that was actually executed to do this read. So let's do that. And if we do that, then we see that it actually, to actually read a variable from the debugger, it actually creates a method do it in, which it hands over the current context. And then it actually calls on this context, it calls a read variable named temp to read the variable. So this is how the debugger can actually read temp variables, global variables, any kind of variable easily, even so it's actually quite complex behind. And if you look at how read variable is implemented, then it's of course exactly what we did before. We just say lookup var, and then reading context self, and it returns the value. So very easy, very nice. What is of course clear is that now that we have first class variables, we could actually get rid of this bit evil transformation step. And that's one of the things that will be one of the next things that is, so we do have a version that then is committed as a pull request, which is on the pull request of Pharo, and you can look at it, where he actually proposes to use a special kind of variable, which is already in the system, which is called do it variable, so that we can actually read this one here instead of doing this whole transformation, which is even slow that we then can just have, oops, it like that, and it would work. And that's nice, and this is one of the next steps that we will do. So this is one of the examples of why is this cool to have objects representing variables, because something that was really complex before is getting really simple using this. Another interesting thing is that I already said that we have the AST and that the variables for temps are living in the AST and they are alive as long as the AST is alive. This is a general thing, so that if you have an AST, the variables inside of the AST are actually annotated with the variable. So for example, if we would take point X, AST, then we get all variable nodes out of it. Oops, it's missing an S. Oop, we get an RB variable node, as you can see here, which is, if you look at it raw, it looks like this. So it has a name, and as we can see here, it has a variable. So that means we can actually ask for variable, and we get back our instance variable slot. And this one is the identical object to if we ask point for its variable using the slot API. So if you do this, it should return true, but why not? Oh, maybe we did. Yeah, it returns true. So that means that the variables are actually annotations on the AST. And this is true for every variable. So every variable on the AST has the information of which variable it actually represents. If you are interested in looking at how this works internally, then you can always look at the compiler, which you look at this, then it's called Opal compiler, and this has somewhere the semantics package, and the semantic package has still some of the variables are part of this package and not part of the AST, which might change in the future to see. And it has at some point, it has the OC semantic analyzer. And this one is the class that actually implements the name analysis. So it takes as an input a refactoring browser AST, how the parser it actually gives us, where every variable use has a new instance of every variable node, and there it actually then tries to make sense of it by adding a scope to the method and to every block, by adding the defined variable into a dictionary of these scopes, and then it uses actually lookup var to do to find actually the variable from the scope. So it really says, okay, lookup var in the scope, and if it's nil, then it's an undeclared variable, and if not, we set it and we return the variable. So kind of nice, and it's actually not that large. So if you look at the semantic analyzer, this is 128 lines of code, plus a second pass with just a little bit of methods to do the closure analysis, which to put the right variables to relook up the variables for the closure semantic. So it's actually quite nice how simple this makes the compiler and how actually understandable it gets. That is that. Then the question is, of course, the compiler. So the compiler now has the AST, it has annotated the AST with all these variable objects. How does the compiler now does bytecode generation? And the answer is, of course, it just delegates it to the variable. So if we go to the compiler, to the translator, and we look in, so we have a normal, so it's an RB program node, visitor, subclass, and at some point there should be a visit variable node there. And there we see what does it do when it sees a variable node. It just says, I don't know, I don't care. I just get the variable object from that node, and I call the emit value method. And emit value, we see we have lots of them, and one of them is actually implemented in the instance variable slot. And this is what you would expect. It actually, we saw when we inspected instance variable slot that it knows the index. So that means it can just say, okay, method builder, push instance variables that index, I'm done. That's everything for me that I know to do. What is nice with that is that the compiler actually knows nothing about reading and writing variables. It just delegates that to the variable itself.
It looked like you had a bunch of other interesting non-traditional Smalltalk ones, like history slot or observe slot. So I take it emits code that does the right thing around the ordinary slot, right reader writer bytecodes.
Exactly. So what it of course means, so if we have now seen variables are normal classes, the compiler delegates code generation to the class. Why don't I make a subclass where I do something else? I mean, nobody forbids me to do that. And I do have actually a small example that I want to show for how you would do that. So let's see. And it's really not long, and it does some real nice example of what you can do with that. So if you think about Smalltalk, variables, you often need the default value for a variable. In Smalltalk, there are two schools of thought, and everyone always decides what to do depending on what is better or not. And one is that you have an initialize method where you assign the variable, and the other one, so that means that the variable is assigned on after new, it gets set. So back in Squeak, long time ago, we actually changed. So original Smalltalk new did not call initialize, so you need to do that always yourself. But it turned out that it's very difficult to explain to students, like, if you want to actually set your variable, you need to go to the meta class before you explain meta classes. And so it was really difficult. And so we did an experiment back then, and we decided we can just call in initialize by default. So that means new calls initialize, and that's what people use often to set variables. So there are a lot of those methods, like 1,700 in the system. Some of them are class side, but most of them are, of course, instance side. So this is how you do it. You just do it there. But then that's often not what you want, because if the variable is accessed very seldomly, you might say, why do I do it on object allocation? That slows down everything. I allocate so many objects and almost never need that state. That makes no sense. And so in that case, people use lazy initialization. So what do? They let it nil, and then they make an accessor. Then they make an implicit, undefined, non-documented rule. In this class, you always need to use the accessor, and in the accessor, they check for nil, and then they return. Well, either they return they assign this value to it, or they just return it because they don't want to even store it in the instance. But the normal thing is to then just assign it to it. This is how it's done in Smalltalk, and it's a bit sad because it means that something that is declaratively known, I mean, I know that this variable should have a default value, is actually moved into a pattern and implemented as code, which is a bit sad because it makes it implicit. So how do you analyze these things? Another thing is that it actually makes it hard to switch from one to the other. So if you have an initialize method and then you say, oh, let's change that instance variable to be lazy, then you need to actually change all the code to always use accessors, then you can do it. And if you then decide to change back, you should actually then remove the accessor use again, which is all not nice. So with this user-defined variables, we could actually make a lazy kind of variable. And let's try to do that, which actually implements lazy variables, but they will not look different to normal variables. So let's do that. We take, we define, so we have instance variable slot, as we know. We make a subclass, lazy initialized instance variable, and there we have a default value inside. So we accept that, and now we have that class. Then we need to define some methods, not that many. So one that we need is we need a print on method that prints actually this variable nicely, because we want to actually have the default in the definition of the variable when it's printed. So that we need, then we need to actually implement a read method, the reflective read method. So do that. So we know instance variables, you read them by having a reflective read method. And this is actually important to implement because this is what the inspector uses to read the object. So if you want the inspector to work, this needs to be implemented. And this is kind of simple because it just says super read. And if it's nil, then we actually write the default, and that's it. And we return the value. Done. Then we need to have an accessor for the default. So because this is what in the class, in the instance creation, we need to call that. And then we need, of course, for the compiler. So one thing is we actually don't need to implement for the compiler now something, because the nice thing is that we do have a fallback. So if we implement read, this is enough because the emit value of the slot superclass actually implements a reflective, the bytecode to do a reflective read. So it calls read. So that means if you don't want to care about bytecode, you can stop now and it would work. But we, of course, want to do the real stuff and we want to generate bytecode. So I prepared that and I will explain how this works. So what we want to generate code for varname if nil varname assigned to the default value. How do we do that? We first push this instance variable itself on the stack, duplicate it, then we push nil, then we send equal because we want to check if it's nil or not, the value that we have. Then we have a jump bytecode. So we jump to target, which is the end, if this is false. If not, so that is the case when it actually is not nil, so if it already has a value. If it's nil, we clean up the stack, then we push our default value, and then we store that in the instance variable, and it's now on top of stack, so everything is nice from the compiler point of view. So we access that, and we are done. And it says inconsistent method classification, so we can actually fix that by, yeah. So it's now nice. Now it has a code generation. So that should be everything that we need to have now a special kind of variable where we can define a default value and it will do everything that a lazy variable would do, but nicer. The only problem is, how can we actually create a class that uses that method? So imagine, so if you have a normal class, so like something like this here, there's only a string here. This is one multi-argument single message sent. There's no space to do any kind of metadata in this class definition because it was not needed. And this is a very simple way of doing things. So what we did actually is to come up with a nicer, we think, class definition form, which actually is much more flexible and allows us to do things like saying this is a special variable, among other things. So this in Pharo, even in Pharo 9, you can just click here on fluid, and then it changes the definition, and then you see how it looks like now. So it's not yet the default. This will hopefully be in Pharo 10, but it needs still some more discussions and thinking. So one thing that I always wanted to do is to maybe rename this to instance variables to kind of make it easier for Smalltalkers to start with it. What you see, this is called fluid because it uses a fluid command pattern where you have always a cascade, and that means that you don't need to make all these methods with these many arguments, and when you then want to add something, then you need to add it to 15 methods. And another thing that this does, which you see, for example, if you go to compiled method, is that it makes the layout explicit. So you don't have anymore this weak subclass, or in compiled method, there was never even, so if you go back here, you see.
Markus, can I just look in for a moment?
Yeah.
I mean, you avoid creating all kinds of constructor methods, but you get to create all kinds of setter methods, which breaks encapsulation. I really hate all these setters. Why would you allow anybody else to set your inner variables? I never.
We don't. So it's a builder pattern to make it easier to have different.
Well, what is layout? What is slots? What is tag? What's package? It's all setters, aren't they?
Yes.
Why? Why do you need to set the layout on a live object?
It's not a live, it's a class. I mean, you do that already in...
A class is a live object.
But you do that already in, so if you go to array.
So what hinders anybody to set layout dash colon to any class or a method or so?
I think we check that it's from the hierarchy.
Well, that's an extra work then.
Yeah. So for example, if you go to array, And you have the normal class definition. You do actually define that it is, you say variable subclass. So it actually has implicit this knowledge.
Yeah,
but it's not extensible.
One method with 4 arguments,
but
you cannot confuse it easily to anything. And
yeah, but imagine you know, but if you now define your own kind of layout, you need to add, for every layout that you define, you need to add all the methods again.
In a simplistic design, yes, of course. And I don't think it's very bad, because you restrict the use of valid combinations of arguments. And now you can create all kinds of invalid combinations of arguments.
No, this actually uses a class definition builder, which checks a lot of stuff.
Well, okay, then you have, well, okay.
Yeah. So it's not that simple. Yeah, it's not that simple. Yeah, I understand. So it's you need to dive on this in this. So what can we? So now, if we want to use our variable, how do we do that? So we saw that we created the class and we created the default accessor. So to define. So if we define a class, a normal instance, so for normal instance variable to not have to write too much, we have a short way. So if you just say here var, then it's a normal instance variable. If you want to make it a special kind of thing, you can use the arrow and give the class. And as this one binds stronger than the keyword, this keyword then is sent to the instance and sets it to 5. And this this defines. Yeah.
Can I ask a question? But you know, if the default is 5, then I don't need a lazy initializer for it. And if it is a more complex object, that it means I have to instantiate it beforehand, and it's not lazy anymore. I don't understand.
Yeah. So I will show what it does now. So if we now so we now created this class, and that means we can. So where do I have my workspace? I can, of course, now instantiate it, and if I inspect it, it tells me that this is 5, but this is only 5 because when the inspector reads the variable, it ends up in this method. So that means, so if we put a halt here and we inspect, it will actually end up here, and it will see that what it actually does is that the variable itself is actually nil in the object, so it's actually not set. And then
that is done lazily, but the default is already instantiated beforehand.
Yeah.
No?
The default is instantiated, yeah, but you can give a selector there, and then it. So this is just the simplest example to give a simple object. But you can in this simple example, I didn't do it, but the idea is that you can calculate, that you can do something like this, or default. I don't know. So this doesn't work. So but you could do it like that. You define default selector, and that would then call calculate var on lazy initialize. But yeah, but it's just an example of how this works. So I actually didn't even show the one that we have in the system, but a simplified version, just to make it easy to see what this does. Because I want to show that if we now make an accessor here, so if we return the variable here, then it looks like a normal variable. But if I now go and inspect the method and look at the bytecode, then I see that it actually does what the bytecode says. If the semantics of this implementation of a lazy is good or not, that can be discussed. This is not even the example that is in the system. It just shows how you can define your own variable and give meaning to, or can change how variables are read and written.
And normally in lazy initialization, you'd be accessing that variable through an accessing method that would do the if nil whatever. But when you're debugging, you often you want to see the object, you know, and if if the variable hasn't been initialized, you want to see the nil because you're like debugging. You don't want to accidentally initialize it by just looking at it, you know. And you know, Smalltalk has a a tradition of sort of blending the ordinary code with the reflective code, and so it's a little hard to separate that out.
That's a question. So you could.
Yeah, so I guess I'm wondering is like, let's say you wanted to have your ordinary lazy initialization scheme where you could still inspect the object, but until the variable was read, not by the inspector, but by the ordinary code, it wouldn't.
That is possible. So for one, you could just not implement the reflective version. Another thing is that you would want, in a system where this is real, you would want to have a way of inspecting this where you see the real version. So the idea is, so the one thing that as soon as we use this for real, we would have another tab where you can see the real state of the object. So right now it's called raw, but this is already in this case the interpreted view of this object. So you could imagine that you could have another tab where you see the real state of the object, for example. But that's to be seen. So we don't use this yet because we do have still on our own many questions. I only used it as an example because it kind of shows multiple things. So how you can define, how you can give state to a variable definition, and how you then can change how the variable actually generates code. But it's not the version that we use in the system. So that was one example. Another one, which I think I will not show too much, is if we look at so we have this context as the variable behind this context. It has a class 2 which implements it, and this one too actually the compiler delegates code generation to it. And one of the things that you can easily do, at least for a simple version that can execute but not yet fully integrated in the system, is that you can make your own kind of variable by just subclassing this, and you could make, for example, this process variable by then in the emit value by just saying push this process, which of course will not safe because this would break everything. But this is possible to actually extend the system for experiments very easily.
You can create like a thread local variable that way.
Yes, exactly. That's possible too. So we do have actually some thread local experiments in it. So we do have process local slots.
Yeah.
So this one, if you look at read, it just reads it. No, how does it work? Oh, I don't know. I think they initialize. Yeah, they initialize actually. So it wraps the variable into a process local variable. That's how it's implemented, which is one way of doing things. So what it does is that it actually on initialize. So when you allocate the object, it actually tells. So if you say once initialize true, it actually delegates initialization to all the slots, and in this case, it will store the process local variable into this variable. This is one way of implementing things. The weak slot is actually implemented like this too. So the weak slot is a slot that wraps a weak area of size 1, and the read then uses at 1, and the write 2 uses at put. And this way, you can actually make a really weak instance variable without having to resort to actually using a pattern where you assign an array of 1 and use that in all the cases. These are some other examples. The question is, what do I have next?
One question for this method: why is the super read used? So that's pretty.
So in this case, yeah, in this case, it's used. So you could actually implement it yourself. So if you.
So what does the read itself does?
So the super read here uses the reflective read. So you could just inline that down below. So you could just use this below. I myself am not sure if this is a nice pattern to use super in that way. It kind of, if you know it, it kind of makes sense, and you say, oh, clever. But when you read it the first time,
method is really very indirect because you have to look at a different method hierarchy.
So I'm tempted to write it like that, to make it explicit. Yeah.
And then you can use self-read. No, you can't.
So you cannot self-read because that would be an infinite loop. That's why it uses super read. So but it's
super read in the right method.
Super read in the right method is not beautiful. That's true.
Yeah.
So when this was suggested the first time, I was looking and I was thinking, do I want that? On the other hand, it does remove code duplication in some way.
Yeah.
But then
it's
it
also
even
very
says
system-oriented code, so
exactly,
you can live with that.
And it even tells you, sends different super message, and it's not really happy about that.
Yeah.
So,
Thanks.
I need to check my plan, what I wanted to do next. So all done. Yeah. So one question is about compatibility. So as you saw, it actually is backward compatible, as you can see, because we use already in Pharo 9, every variable has this object behind, and it still uses the same class definition. And so it's actually, if you use just the feature of Smalltalk 80, it's backward compatible to Smalltalk 80. And you could easily write, for example, a checker that warns you if you use some feature that would be not backward compatible. So that's kind of nice because it allows people to actually not use it. We ourselves don't use it too much because we are still learning. So we realize that you need to actually use stuff in experiments before you use it in the system itself. So that's why there are some examples in the system, but they are not used yet too much. They are there to actually start to use them in our own code, to get used to it, and then to find out the problems with this approach and to then improve it. Another thing is that the reflective API is still compatible. So that means we have still insta-add, for example, it's still there, all these things. So that's kind of nice. So partly because all the reflective methods of Smalltalk 80 use a short form. This means that then we can use the long form to operate on objects instead of strings or offsets, which is nice. Of course, the compatibility the other way around. So if you use it, then of course it's a bit difficult to go back. I think for some usages you could invent refactorings to go back. So for example, if you use the weak slot, you could actually do code generation and then file it out in a compatible way. But the question then is, of course, does it make sense? To me, I always found this idea fascinating that the programming language is a medium that when you then provide some new abstractions, that it actually makes you more powerful, which I'm still a huge fan of this view. So where do we use it? As I said, we are a bit careful to not overuse it before we are not sure that it is a good idea. It is actually internal use, so that means the instance variables are objects, the debugger and uses the variable read methods. The compiler uses the variables internally, but of course before it used its own objects for that. We did replace the debugger method map with it, so there is no debugger method map anymore for reading temporary variables. This is all done via the variable objects, and we started to use one one thing more. So observable slot is actually one of I think the only special kind of variable that we use a lot right now. And this is used in the user interface because it allows you to define variables that when they change, notify the program that the variable changed, and then it can update the view. That's kind of nice. The next steps that we want to actually explore with this. So one thing, we have the idea to use do-it variable for nicer do-it-in methods, so that we don't need to do code generation code transformation anymore for evaluating against the context. One thing that came up is undeclared variables. So we right now in the system, like an undeclared variable, it's like in Smalltalk 80, so it's just an undeclared variable, but it lives in the undeclared dictionary. And when you read it in, it's nil. And if you write it, all undeclared variables share the same value. And the question there is if we do not do something more clever. So one idea was to actually not, when a variable is undeclared, to immediately interrupt the programmer to say, oh, please define it, but to do it actually a bit later and to actually have something that at runtime, actually, when you are in development mode, would actually ask you, oh, you're reading an undefined variable, don't you want to do something? There is already some code in the system that does exactly that, because it's actually needed when you do test first development and you actually have an undeclared variable. You don't want to get the error nil, some message was sent to nil. What you want is, you want to get a notification, hey, there is an undefined variable, do you want to define a class? And that's right now done by actually hooking into does not understand. So that means does not understand on nil, analyzes the situation and says, oh, I think this is the kind of situation where someone is sending a message to an undefined variable. But of course, it's more like an ad hoc way of doing it. And with undeclared variables, this can be done much better.
Since the variables in undeclared are static bindings, what about just putting like a halt in the value or something more sophisticated, the value method?
Yeah, exactly. Something like that. So to open so one thing is, you don't want to have it in the, so you do want to check if you are in development mode or not. But yes, to then open a debugger and say, oh, do something. Or to open a dialog for class, for globals, like define a global, define a class.
It's a little scary about what I think I want access to undeclared variable to do in production.
Yeah, that's why it needs to be done carefully. So one thing is, so right now in a non-interactive mode, which would be what you do in production, it actually just reads an undeclared variable as nil, which is not too bad, but we could do the same. Another thing is that we of course check, so we have release checks that you can use in your own projects too, that checks that there are no undeclared variables. So it's more something that happens in development, I think. And for that, it would be nice to have something that on execution asks the user what to do. And it could even, one thing I want to do is to make a teachable undeclared that actually starts, that actually analyzes, oh, who actually accesses me? And when it then sees it's only in one class, in one method, it actually assumes it's a temp. If it's in multiple methods, it assumes that it's instance state, which of course will not be correct, but it's better than just a global value. So kind of like a teachable undeclared would be fun too, in case nobody wants to define it. Yeah, then this process variable is something that we are thinking about in Pharo 10, because it's actually nice to be able to ask for the current process without, so right now it's process current process, but the message sent itself is an interrupt point, which is a bit sad. So it would be nice to maybe nice to do that, but it's not yet decided, but it's one of the ideas. And another thing that we saw some use for is weak slot, to actually make it really explicit. This is a normal instance variable, but it's weak. That might be nice to use for some cases.
Marcus, just an idea. What about like foreign objects, where you could maybe model the various C interpretations of variables?
Yeah. So we actually, yeah, that's true. So that's something that actually we did already experiments on. The idea is that for this, you would need to define your own layout, which is possible because layouts are now classes too. You can make subclasses. And we did have an example where it was done that someone made a special layout that defines a kind of like a bit pattern, and then slots that then say, well, yeah, and I am writing in this pattern like that.
Yeah.
So that's something that could be very interesting, because it could allow you to access C structs in a very nice way, for example, in FFI. It's something that would be nice. Another thing that for the class definition that we were thinking about is, so one thing that happened is that people always complain. So we do have in the browser something that tells you this, you need to implement this method because it's subclass responsibility. And then you say, no, this is just not in this class, in its subclass, yes. So that means you need to somehow be able to declare a class as abstract. Right? And we did it now by putting methods on the class side, but that's really ugly. And so we were thinking, maybe we can add that metadata to the class definition, like this class is abstract. Another thing is that maybe we could have pragmas for classes, so people could use them and abuse them for strange stuff. And another kind of information could be the compiler to use. So in Smalltalk 80, it's traditional that there is on the class side, that this is defined on the class side, but the question is always, if I change the compiler to a compiler of another language, how can it compile this first method? Doesn't really work. So that could be too a thing that we could do declaratively on the class definition, like this class and all its subclasses. This is the name of the compiler to use, the class of the compiler to use, or the parser. Things like that. And another thing that we are looking into now, and which will be done the next weeks, is to extend the meta-link model to allow meta-links on variables. So right now, meta-links are is a way of defining a message send that you then can annotate on AST nodes. And every time the operation that this AST node defines is executed, the message send is executed. And this is a little bit related. Yeah, it allows you to define meta object protocols very easily. You can say, in this class, all message sends use this message sender implementation, for example, or you can do logging or tools with this easily. For example, breakpoints in Pharo use that functionality. And we do have breakpoints on instance variables too now. But they actually go to the variable, check for all AST nodes that assign the variable, and then they put the meta link there. And there we want to extend the model that we can put breakpoints directly on variables instead of doing it with more work. So for example, breakpoints are now defined as put a breakpoint in this class and this name of instance variable. And instead we can, of course, now use the objects, which will make things much easier. And then another thing is where we did some experiments but have not yet a good solution is it would be nice if we could actually have some kind of a composition for typical features. So imagine this idea of having a default value independently of laziness, just the default value. You want that for slots, but you want that for class variables too. And could we not implement that once as some kind of decorator and then kind of compose them together easily? But that's not easy because it gets quite hairy very quickly, and at some point so we did some experiments, but it looked too complex. But that's something that would be nice in the future. So that is what I want to say. One thing that I should say is that this is the work of many, many contributors over the last years in the community, who contributed discussions, ideas, code, bugs, bug fixes, all of these things. And it was a very nice experience, and it was a lot of fun. And I hope that we will continue with that and iron out all the remaining problems and build something nice out of this step by step. So that is,
I noticed. Yeah. I like the way this takes basically this basic functionality of reading and writing a box, let's just call it, and abstracting it and sort of refactoring all of the common things we normally do as software patterns into something more formal. And one of the ones that I would think of the big bang for the buck, I noticed you have like the relation slot with the to many and to one there.
Exactly.
That seems like a particular weak variables. I mean, that's cool, but I mean, how often do you actually do that? But that seems like it would give in this approach one of the biggest bangs for the buck.
Yeah. So one thing that I like is that it makes the kind of graph of the objects. You can give meaning, so you can give more meaning to the graph too. So for one, what happens when you change it? Another thing is that you can actually annotate it with meta information easily. So that's things that we need to explore. So one idea that we had was to actually be able to write very generic reflective visitors where you say, please follow, this is the root of the graph, please follow all state that is tagged children. And then you can tag your instance variables that you're interested in with children as metadata, and then you could make a visitor out of nothing, which would even be able to visit without sending messages to the objects. So these are the things. But yeah, relationship slots is one of the things that we want to definitely explore, because that's really where a lot of pattern code is always implemented again and again and again. Yeah.
So what does this has an impact on runtime code, especially the runtime of it? I understand that it takes more space, but does it actually take more time too?
No. So it's space, yes. So you pay for the objects that are there. So 12,000 instance variable meta objects with 4 instance variable each. That's memory. That's clear. But from the speed, it generates exactly the same code as before. So that was a bit the goal of this. So the idea was that we didn't want to build something out of nothing, where we might build something nicer overall, but we would never be able to use it. So the idea was for this one to actually start with the Smalltalk 80 system and to see how far can we get by keeping it the same. So the code is really the same that it generates for standard instance variables. And the only thing, that's the same. The only thing that we need to think about is a bit this notion of slots that want to get initialized, so that want to get the instance handed over to initialize it. That is right now done on demand by adding. So it actually analyzes, does the class already have an initialize? If not, create it. If yes, add it as a last line. And that's a bit ugly. There, we are thinking of actually, we would like to add some metadata to the class, like or to see maybe we have already some flags left that we can use from the VM to see if we could not encode that information at compile time to say this class needs initialize of the slots because the slots want it. And then the new in the VM would actually look, oh, this flag is set, I need to actually do this. That's something that we need to look at. That's the only thing. So was one thing that could have made the system slower, but we have a workaround by actually doing the code generation for now.
From a Lisp point of view, it seems vaguely macroish, especially like with setf, generalized variables. I don't know if you've done any Lisp.
Not actively. I read things about Lisp and about meta object protocol stuff there.
It's similar. I mean, I really like the way you're pushing the meta object protocol here. I think it's really cool. And Lisp does a lot of this stuff, but the syntax just drives me nuts. It seems so much nicer in Smalltalk. But it's think of like generalized accessors. So for instance, imagine you have the way in C you could go C of I. If C was an array, you can go C of N gets something, and it's really like an @ put : L values.
Yeah.
I mean, it's sort of expanding that whole idea of there's like for a particular identifier that's is a variable, there's a way of getting it and a way of putting it. In general, the whole concept.
Yeah. So one example that we added, where is it? So we do have a Boolean slot, which actually gathers all the Boolean slots of the hierarchy and stores it in one integer. And then
I didn't quite understand that.
And then it actually generates the code to actually do the bit add.
Ah, I got it. So you can bid encode. If you have a bunch of Boolean variables, you can bid encode.
And so, and that's actually quite nice because it looks nice if you have Boolean instance variables like flags and UI systems, but it uses a lot of memory, of course, because over 64-bit. And with this, you can just combine them all into one instance variable.
Yeah, the behavior format variable would be a perfect thing to use this for.
Yeah. Or another thing that we have a property slot which installs it into a dictionary so that you can add lots and lots of instance variables and you only have one dictionary and another one. So Smalltalk, even so the bytecode got better and we don't have that many problems anymore. But it used to be that at some point we could only have 125 instance variables, 24, and that people had problems with that. So when they did code generation, and so we actually implemented one version where we actually store the state in an array, so that every time the object has one instance variable and that instance variable is an array, and then all the state is actually stored there. So that was another experiment that we did at some point.
I got a friend who did a macro package for Smalltalk. It was just more of an experiment just to see what macro was like. And it was nice because you could do very similar stuff like this. I noticed when you did it in the compiler where you're using the emit value as opposed to like an AST transformation, which would be more traditional for macros.
Yeah. So one thing is that this notion of that you have to write the bytecode yourself. This was the easiest thing to do.
I noticed like you got these methods that are just going like when you're on now, it's like add, push, pour, stop.
Exactly.
And you're going to blow the stack alignment and the VM's just going to blow chunks.
Exactly. So the thing is that there is the question, can we not replace this with some AST manipulation and make it more clean?
That's the appeal of macros. Is you can leverage the ordinary compiler to maintain, make sure that the bytecode emitted is safe.
Yeah. So that's something that we need to definitely explore. So this one came just out of how it was working. So this was very natural to put the emit method that was already there onto the variable, and then it was very natural to just subclass it. But of course, you don't want to deal with this code because it's very hard to write. Another thing is that you cannot just use the reflective methods because they often use different slower codes to actually do the read. So that means we need to have some kind of AST transformation-based approach for this. That's definitely clear. Now, so that is.
Can I ask a question?
Yeah. So now we have time for question.
Yeah. Can you now also type your instance variables or your variables, like make the point X a number and make rectangle points and stuff like that?
So we did have experiments with that. So you can, because the object that represents the variable can easily now store metadata, and some metadata of that can be type information. So you could very easily build a typed slot. And we do have actually a package somewhere on Git where a student actually implemented a fairly extensive version of that. The question is, do you really want that in practice? So, but it's definitely an interesting direction that one can take.
There are all sorts of other live constraints you could put on slots.
Yeah.
Quite apart from typing.
That's true, yeah. You could, for example, you could have meta information that you use for user interfaces, which would go a bit in the direction of Magritte, is I think the name. So in Smalltalk, a lot of people implemented meta frameworks that actually use just methods on the class side to add metadata. So there were lots in the 90s, there were lots of experiments of frame-based systems, for example, that generalized Smalltalk classes into frames. But they did it always by adding metadata on the class side as methods that need to be executed. And Magritte is a system where you actually have class side methods that describe the variable. It says, okay, name is a string and it is maximally 30 characters. And then it's not used by the compiler, but it's used by the UI framework so that it can then automatically generate a viewer for your class, which looks actually like a user interface. And that's extremely powerful. And it would be interesting to see if that makes sense to put that on the slots themselves. The question, of course, or the negative side is, which we saw already with this when we experimented with slot composition, is that then the class definition gets really heavy. And so the question is, where is the sweet spot with these things? So you can easily build something that then looks far too complex on the class definition. But it could be interesting. And definitely as a place to put the information, so even if it's stored somewhere else and not shown directly here, the nice thing is that now all slots do have a property API already. So so what we did in Pharo is that every structural element in the system, classes, methods, AST nodes, and variables, have a property API. And you can put metadata on them without having to make a subclass. And that can be quite useful, especially for experiments or for metadata. So for example, in Smalltalk 80, the question if a class was obsolete or not was encoded in the name. So you have an obsolete. Is it an obsolete? I think so. And this is now actually a property. So if we go to I think it's this one here in class. It actually puts a property on the class, property at absolute put true, which is nice because this way we are independent of the name of the class. We don't need to change the name. We still do it for the end user, but we don't use the name to check for obsolete. And this kind of possibility to add actually metadata to structure is very powerful and can be quite nice. And this can be done for all variables. So every variable has the same API, so it's unified over the whole system, and every variable can use properties.
Would this allow you to build a better coverage framework, for example, that would tell you exactly
that is possible? Yes, exactly. So you can actually you could, using, for example, metalinks, you could hook into read and write of the variable, or and and then tell the system when this variable is accessed, please tag the variable as used. And this way you could then later look at all your variables and see, oh, I run the test, it's not used, for example. But that's possible.
So I'm a fan of immutable objects. And I guess you can implement like immutability by using just read-only slots. Did you do that, or is that a different mechanism?
That could be possible. One would need to think about it a bit. But you could do that. So, but the question is, of course, how do you control when it starts to be immutable? But that could be interesting.
It needs to be initialized at some point.
Yeah, exactly. But then it could be possible. Yeah.
Visualworks has a mutability flag for objects at the VM level. I don't know about Squeak.
We do that too. So, and we actually now already all literals are actually.
Of course, part of the fun of Smalltalk is just playing around and modifying things as you're like hacking around to make it do what you want. And so, there's this tension between, I want to program in a functional immutable style, but I'm like in the debugger, and it's like, I really want to modify this just because I'm like deep in my code. And it's hard for the system to know whether you're doing something because you really know what you're doing and it's a debugging thing versus, no, this shouldn't happen ordinarily.
I mean, for the literals, we did it because did you ever have a bug with that? So I remember that when I was a student, I wasted a day and started to get insane because I was just returning a string and it was a different object and I didn't understand why. And I recompiled, it was fixed, I ran the test, it broke. stress and test twice, and like, how can that be? And then I realized I modified the literal string, and I didn't realize. And that's why now it raises an exception. You can of course then do whatever you want by reacting on the exception.
I was always amazed in the early days of Smalltalk when literals were mutable, how rarely that actually happened.
Exactly. I mean, that's true.
I remember when I was like teaching someone early on Smalltalk, and he did ordered collection gets 5. And of course, those bindings or in modern Smalltalks, those bindings, you can't just change them that way. But this leads me into this is going to lead me into sort of this side project I've had over the decades of doing something similar, but instead of reifying instance variables, reifying message names, which you could call selectors at the implementation level, which in Smalltalk are, of course, symbols. And if there was ever something that's immutable, there are symbols. And I've often had to like mutate symbols to turn them more into a reified generic function or message name.
Yeah, that's interesting.
I'm more familiar with VisualWorks, so most of my experiments are in VisualWorks. And like just in preparation for your talk, I tried to like dust it off and try it out. I was on an older Smalltalk because that's all I had at that time. But so I would take something like a byte symbol, which is the concrete class for a symbol that's just ordinary ASCII. And I would change its class to a byte selector, or I'd want to, but it was marked immutable. So of course, you'll flip the bit, change the class, put it back in, and then confusion happens because it confuses symbols and interning.
Yeah, the problem is that symbols manage there's only one instance of the symbol in the whole system.
Right. And I wanted to maintain that, but I would modify the class of the symbol to be a selector. But the interning mechanism, and like I say, this is an older version of VisualWorks, and I actually like dug into it. And there was this primitive method that was sped up to like just do a string search in an array to find something matching in the symbol table. And the primitive checks that the classes are the same, but the fallback code in the primitive just checked the actual byte. So all I had to do was comment out the primitive and everything worked.
Yeah. I think that because there are so many so many symbols in the system, there are some ugly speed up code in the class. Yeah.
But
yeah, that's interesting. That it was
nice to have just like it's irritating in like normal Smalltalk that instance variables are really just a string that's their name.
Yeah.
And I like the way you reified them. It would be nice to sort of reify
to do the same with the selectors.
Symbols into something more like a generic function.
Yeah, that's an interesting idea. Yeah.
And it turns out every Smalltalk VM I've ever seen doesn't really care what the actual selector is. It just has to be an object, usually not an immediate.
Yeah, I think that this was actually done very early to be able to compress the system by just not needing to store the symbols. So to have an image shrinker that actually replaces all symbols by small integers.
Yeah, and good luck hunting down every place you do perform.
Exactly. So this is only possible for a small subset. But I think that was really made with intention for this feature.
I have a suggestion for another experiment. And what I'm particularly thinking about is multi-core, where you have usually a nursery per core, where there's no problem with you're using an accessor directly, but then something gets garbage collected and promoted to a global area that is accessed by multiple cores. And in that case, you'd almost like to have, I think of like virtual memory where you can dual map it and one view can write and the other one can't, anyway. But you could almost do an experiment here, I would think, of having two different types of, based on where in memory something is, having the accessors be slightly different.
Mhm.
Yeah,
So
that would actually be kind of cool if you had a multi-threaded Smalltalk for shared variables emitting code that puts the proper memory barriers around. That would actually be very cool.
Yeah, and actually you could do it using the Spur memory format by having if you have little two sibling subclasses that only differ in how the accessors are done. And all you have to do is change the class ID and hash to be one of the two subclasses, and all of it, you know, to swap between the states of those two. So it wouldn't necessarily be expensive or difficult to try it out. Anyway, just
nice. Yeah, that's nice.
I have a question actually for Hernan, if he's still around. Yeah, I was just wondering, you know, whether it would be possible if live typing were to be ported to Pharo to reuse all this infrastructure that is now available to simplify the system. Is Hernan here? It looks like he left. Oh, well, that was something I was wondering. Marcus, would you have any opinion on this?
So what do you want to simplify exactly?
Well, live typing stores a bunch of
live
information,
typing,
right?
Yeah.
Yeah. So whether, since we now got something where you can annotate slots and every other element of the AST, whether, you know, a port of live typing to Pharo could make use of that.
I think you could do that. So the problem with doing these things, not in the VM but in the image, that the performance might suffer. So if you because if you replace something that used to be a bytecode, like accessing a variable, and you replace it by something that calls 20 methods, it will slow down everything quite a lot. So that's why one needs to be a bit careful of using reflective features because it can slow down things quite considerably. That's why I think they took the approach to do it on the VM level, because there you can do it in a more controlled way for performance. But from a feature perspective, yes, especially as soon as we have meta links on variables, you can just put a meta link and say, whenever you get assigned, call this, send this message. So here's the meta object, this is the selector, please give me the class of the value, and then you can store it somewhere and it will work. The only question is, would it be fast enough?
Yeah, of course.
No, but yes, that could be done. And you could even store this information in the maybe even in a property on the variable, for example. Then you even have a nice space for this meta information. But the question is always, will it not blow up? For example, a property dictionary takes quite some memory compared to having something in the VM where you have some flags for some data. But yeah, but it's definitely something that could be done.
Okay.